Hi class, we're going to learn a lot of different ways to represent data that's found in chapter 10. So first we're going to start with a set of data. What I have here is a sample of different temperatures that were taken in December. I believe that there are 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Awesome. So we're going to learn 7 different ways to represent this data. The first way you're very familiar with, it's called the mean. And when we are talking about the mean, we're talking about the average. And when we do that, we are going to take all of the points in our data set, add them together, and then divide by the total number of items in our data, which is 9. And so when I add this together, and you can use a calculator, you're going to find that they add up to 414 divided by 9, which is 46 degrees. So the mean is 46 degrees, or the average. Okay? So that's the first kind. You're probably very familiar with that. The second way that we're going to represent this data is with the median. And what's important with the median is, first of all, you need to line up all of your numbers in order, from the smallest to the largest. And what we're looking for is the middle number. That's what median is. Just like on a freeway, the median is right in the middle of the freeway. So try to think about that. So we're kind of fortunate that we have an odd number of data. And so I'm just going to keep going all the way until I find that very middle number. So that means that the median is going to be the number 48. Pretty easy, as long as you have them all in number order. Now, if there were 2 numbers that are in the middle, you simply add them together and divide by 2, just like the average or the mean that we did up above. The third way that we're going to represent data is by finding the mode. So if you recall, when we find the mode, really all that we're looking for is the most common number. So which one is the most common? And it's kind of easy. I can look here, and really the only number that ever repeats itself is 48 degrees. If there were 2 instances where both numbers were being repeated the same number of times, then both of those would be the mode. They would just kind of share that award. The last one that I'm going to do is the range. Okay, so when we are finding the range, what I want to look for is kind of the span from the largest to the smallest. And so what we're going to do is we're going to take the largest number and we're going to subtract the smallest. And that's going to give us the range, or the span. So maybe you want to say the span. How far apart from the largest to the smallest are all of your items? So in this case, the largest number is 53. The smallest number is 31. So the range is 22 degrees. So in those 9 days, there was a difference of 22 degrees from the coldest day to the hottest day. So if I'm looking at all of these 4 different ways to represent my data, I would actually say that the median and the mode, which both gave me 48 degrees, would be the best representation of this data, because most of the temps as I'm looking are pretty close to 48 degrees. I have this 31 that's pretty far away, and that kind of affected the mean, or the average, by making it a little bit lower. But most of them are around 48 degrees. So that's why if I was going to make some notes about which one I think best represented my data, then I would probably go with the median or the mode. And this can change every single time. All right. The next way that I'm going to ask you to represent data is by making a stem and leaf plot. So I'm not sure if you've done this before, but when we make a stem and leaf plot, I just find it easiest to put all of your data points in order. So you already have this on your paper because you just lined them all up when you found the median. I'm just rewriting it again right here. So now that I have them in order, what I'm going to do is I'm going to organize them into 2 columns. So every time we're going to just draw a line. One side we're going to label the stem, and the other side is going to be our leaves. And what we're looking for our stem is typically, if it's a 2-digit number, the first digit, which would that we see, which is going to be the tens, I'm going to put as the stem. So I have a 3. I also have some that are starting with a 4, and I have others beginning with a 5. And then I'm just going to go one at a time, and for the leaves, I'm going to put the ones digit. So for 31, I'm going to put, I have a 3 there for the leaf. I'm just going to add a 1. So this is an abbreviated way of writing 31. For 42, I'm going to add a 2. For 44, I'm going to add a 4. And you'll notice I'm not putting any commas. For 46, I'm going to put a 6. For 48, I'm going to add an 8. And I have 48 again. I need to put it again. Then for 50, I'm going to go on down, add a 0. For 52, add a 2. And for 53, add a 3. And this is primarily it for making our stem and leaf plot. So it's kind of showing us how many of our values were in the 30s, how many of them were in the 40s, how many of them were in the 50s. The last thing that you need to make sure that you do for this type of graph is to make a key. So if someone is just looking at your stem and leaf plot and they're wondering, well, what is this even talking about? Is it talking about number of students in a school? Is it talking about how much shoes are costing? If we want them to know that it's talking about temperatures, then we'll make a key, and you just pick any example that you want. How about I pick the 4 and the 2? So I'm going to write a 4, I'm going to make a line and a 2, so it's kind of like a mini stem and leaf plot. And I'm going to say that this really equals 42 degrees. And that's it for my stem and leaf plot. So the reason why it's kind of nice to have your data represented this way is I can look, where do I see a lot of the values? And so what I would say is that most of the data, based on the stem and leaf plot, was above 42 degrees, right? Look at all of these that are above 42 degrees, except for that one very cold day in December that was at 31. All right, so this is just another way to interpret your data. So let's move on to our next way of representing data. It is called a histogram. So for a histogram, you need your data again, and you don't need to copy this down every single time. You have it on your paper. So I have all of our temperatures again. When you make a histogram, the first thing that you need to do is you need to make a frequency table. And I just put in parentheses to choose small intervals. Now you might be asking, what is a frequency table? Well, what it is it's a table that you make by making tallies. So I'm going to choose some intervals for all of my data. And I saw that they were ranging from 31 all the way up to, I believe it was 53. So I'm going to make some intervals right here. I'm going to say, and you want them to be kind of small, so I'm going to say maybe my first group is going to be from 30 degrees to 34 degrees. So maybe each interval I'll make it just about 5 degrees. So the next one will be 35 degrees to 39 degrees. The next interval, 40 degrees to 44 degrees. My next interval, 45 degrees to 49 degrees. And 50 degrees to 54 degrees. It's really important that all of your intervals have the same number of values in them. So from 30 to 34, I have 30, 31, 32, 33, 34. So I have 5 degrees. And same with all the rest of them. So I'm good so far. So now let's go through our data and we're just going to put a tally in that interval whenever one of our temperatures falls in it. So 52 degrees, we'll put a tally down below, 48 degrees, 31 degrees, 48 degrees again, 50 degrees, 53 degrees, 46 degrees, 42 degrees, and 44 degrees. So this is the first step. You have to make a frequency table. Okay? So I think it's pretty easy. The hard part might be choosing your intervals, but you just want them to be fairly small, not tiny, but you don't want them to be really big either. So you want to end up with maybe at least 5 different sections. So then we're going to use this to create our histogram. So I went ahead and I started to draw the base of what our histogram is going to look like. And so what it's going to be is it's going to be only in the positive quadrant if we were going to graph things. On the bottom, I'm going to put what I had for my intervals. And you'll see here that I made even spaces and I labeled those different intervals. So from 30 to 34 degrees, 35 to 39 degrees, 40 to 44 degrees, 45 to 49 degrees, and 50 to 54 degrees. And then going up, I labeled the number of days in December, which was my second column of my frequency table. So 1, 2, 3, 4, and I don't need to label any further than that because my data doesn't go any further. So I have a title, and I have done all my labeling. So now what I'm going to do is, if I have one day in the range between 30 and 34, I'm going to make kind of like a, I guess, a little mini building that just goes up one step. Okay. And I would do some shading. Your shading is going to be a lot better than mine. The next interval, I don't have anything there, so I'm going to skip it. The next interval from 40 to 44 is going up 2. So I'm going to look, where's my 2? I'm going to draw my little building that's going up 2. And I'll shade that. And the next interval is going up 3. I can shade this interval. And the last one is also at 3. So it's kind of nice, it's right there. And I'll shade that. And that's a histogram. So it's not too hard. But it's kind of nice because it shows you maybe if there's gaps in your data, which the other ones didn't really show us that as well. So there's the 6th kind of representation for data. And let's move on to our last one now. It's called a box and whisker plot. And when you look at the final product, that's exactly what it looks like. It looks exactly like a box with some whiskers. So what's important is for you to have your data in order. So I have my data in order. I'd like you to copy it down one more time because we're going to label some things on all of these values that are in order right now. The first thing that I want you to label is the median. So again, the median was that very middle number, 48. Okay, this is the median. Let's label that. All right, and this is something that we are going to plot. We're going to make it as a point. So I'm just going to kind of give myself a little star there to make sure that I plot that point. And so once you have the median, the section above of all those that are remaining is called the upper half. So let's label that upper half. And the values that are below the median is called the lower half. Okay, awesome. The next thing that we're going to do is we're going to circle the minimum value. So 31 in this case is the minimum. And we're going to circle the maximum value, which was 53. And I'm going to star both of those to make sure that I plot those points as well. And then I have one more part. Okay. In this lower half of these four values, I want to find what is in the middle, or what's the median of all of those. And so, since there's not an actual number that's right in the middle, what you want to do is, since these two are both in the middle, let's take the average of them, which the number right in between is 43. And this is going to be another number that I plot. This is called the lower quartile. Q-U-A-R-T-I-L-E. And this is something else that I need to plot. So see why I really wanted you to rewrite this, because there's a lot to do. And then looking at the upper half, those top four, I'm going to find the median of those. And since there's not an exact median, let's find it. Between 50 and 52 is the number 51. This one is called the upper quartile. Okay, so that's it. So now on to our drawing. So what I drew here was a line that just has everything evenly spaced out. Okay, and what I'm going to do is I'm going to label it. So since my values are kind of between 30 and 55, that's what all my points are going to be. So I'm going to go counting by 5. So 30, 35, 40, 45, 50, and 55. Okay. The first thing that I want you to plot is a dot for your median. So the median is about 48, and you're going to always do this below your number line. Okay. And then let's go ahead and plot the lower quartile and the upper quartile. So the lower quartile is at 43, so that's about right here. And 51, which is about right here. Okay, and with these points, I'm going to make a box. So I'm going to connect the points on the outside to make a box, and then I'm going to draw a line straight through that median. And let's go ahead and label all of those. So this was at 43, the median was at 48, and the upper quartile was at 51. Okay. And then I still have the minimum and the maximum that I need to draw points for. So the minimum was all the way at 31. The maximum was at 53. And now we connect these to make our whiskers. It's just a single line. So this was 31, I'm going to label it, and 53. And we are done. This is a box and whisker plot. And so what's kind of cool about it is that it shows each section the 25% of your data. So we could see here from 31 to 43, that's 25% of my data. But like this tiny section, that means that there's a lot of numbers right near one another between 51 and 53, which is also 25% of our data. So I know that this was a long section, but we're going to do a lot of work together in class and get really good at representing our data.